Hi, let's talk about molecular solids. So molecular solids, this happens between a nonmetal and a nonmetal. It's really just covalent bonding. That's where we come and share electrons. But we call these molecular solids in contrast to like a covalent network solid, ionic solid, metallic solid. Now, our molecular solids, we use the word molecules. This is the only time that we can use the word molecule in chemistry. They have very low melting points and boiling points, and it's because there are weak intermolecular forces. So remember, changing phases, it all deals with those forces, intermolecular forces that hold the molecules together. You're thinking hydrogen bonding, dipole, and London dispersion forces, okay? Now these are considered weak in comparison to what you would see in like an ionic solid, where it's the Coulombic attraction, that full positive, full negative cation, anion. These are going to be weaker. That's why they have lower melting points and boiling points. It's easier, it takes less energy to change phase because you're overcoming those intermolecular forces. They do not conduct in aqueous form if they dissolve, liquid, which they usually don't dissolve, liquid or solids. And it's because those electrons are held tightly in that sigma bond, sigma or pi bonds for that matter. So the electrons are held tightly, they don't conduct. We can't have a current flow because electrons aren't moving. Now there is an exception to that. Polar covalent will slightly conduct. Okay, polar covalent molecules will slightly conduct because they have a partial positive and a partial negative. So there can be just a little bit of conduction there. Now, what holds these molecular solids as a solid or holds them as a liquid, let's say that we put in energy, it melts, is 100% the intermolecular forces, hydrogen bonding, dipole, London dispersion. Now the intermolecular forces, remember that's what explains the hardness of that substance, its melting point, boiling point, vapor pressure, and solubility. And what you'll recall is as you increase intermolecular forces, you're going to increase the melting point and boiling point. You're going to decrease the vapor pressure. Now I have several videos on intermolecular forces. I mean, probably a half dozen at least. If you have questions on this, solubility, the impact of IMF, go to Lean Think and you can get more than you'll want, more information that you want. So you'll be ready and well learned. Now, our molecular solids, these can be really large polymers. They can be both synthetic and natural forming. They have really important commercial and biological purposes. Some fun examples for you. Kevlar. Kevlar is going to be a polymer. That's what we use inside of tires. We use it as bulletproof vests. Really cool stuff. An example of a natural one, actually polyester. It's inside of waxy leaves. We copied it and made clothes out of it, polyester. So tons and tons of biological and commercial applications for really, really large polymers. Nylon, plastics, they're all polymers. Okay, nice. So there you have molecular solids. It's just covalent bonding in a solid form. And the key to this, intermolecular forces. All right, have a great day. Thank you.